Hi, hopefully you were able to finish the exercise and you were able to get the state table as shown here. Now, uh, it looks when you look at this circuit that there are five states, right? V, W, X, Y, and Z. But if you look at the state table carefully, what you would see is actually there are only three states. Now, why am I saying that? Now, take a look at this. Take a take a look at compare, for example, the states W and X. What do you see? So if you have a zero input, from W you go to Y, and from W you go to V. Similarly, in X also you have same Y, V, and the outputs are also the same. So in one sense, the states W and X don't seem to be two different states, right? They are exactly the same. Even if I combine both these states, I'm not going to lose anything, because if you are in W or if you are in X, what you have is exactly the same state transitions. So basically, these two states are, let's say, you can say that these two states are actually the same state, or they can be combined into one state, and still the functioning of the circuit is going to be exactly the same, right? Hopefully that makes sense. So what you can say then is that you can completely delete one row of your circuit. And the reason why we are doing that is because if you have duplicate states, so let's say you have five states, okay? So five states cannot be implemented by two flip-flops, right? To get five states, you need at least three flip-flops, because two flip-flops can only do four states, right? But now that we have simplified our state diagram, we can say, oh, we can implement this with just two flip-flops. Is there any other combination of inputs which you think are redundant, or any other states which are redundant? Maybe pause the video and you can think about it. But if you don't want to do that, if you just want to continue, take a look at this state, the state V and the state Z. They also are exactly the same, right? Because you have VW01 here, you have VW01 here. So basically, this state is a redundant state. So in that sense, so what we can do is we can actually combine state V and state Z. So state V and state Z basically are the same state. Okay, and if we combine these, so if we combine W and X, and if we combine V and Z, you get a state diagram, a state table, and a state diagram with only three states in it, and that is much easier to design than a five state table. So as an exercise, why don't you try to redraw the state diagram for this particular reduced state table, and write the state table for, so write the state table and then draw the state diagram for the reduced sequential circuit that we are looking here.